So. Okay. So, hi, we are Accso from Darmstadt, Cologne, and Munich. We're going to talk about real-world objects in virtual reality today. I'm Aurelius. This is Mike, and later today you're going to see Alexander in a workshop for WebVR, just like Fabian told us. And we're here to entertain you today, although our specialty is IT consulting, not games. And as you can see here, we call ourselves Axonauts because we try to capture the spirit, the pioneering spirit of astronauts, but mainly because it sounds cool. And however, virtual reality is a field with still a lot to discover and experiment on. So in a way, everyone, each of you who's interested enough to come today is a pioneer in his or her own right. Since we focus on industrial software projects, we want to use virtual reality for learning and analyzing and for experiencing and understanding. And to accomplish this, we use tools like sensors, trackers, and as you can see here in the upper left, infrared cameras in the form of leap motion gadgets. Those are the little rectangular gadgets you can see on top of the head-mounted device. And with this tool, we are able to capture our hands as real-world objects in virtual reality and project them onto virtual hands. This allows us to do much more delicate movements in virtual reality. You can try this out later on our demo over there on the carpet. But of course, we want to think bigger than that. We want to capture entire machines like vehicles in virtual reality. And our vision is portrayed pretty well by the recent Marvel movie Black Panther. As you can see here, there's a little tracker on top of a car which captures the car and projects it into a completely different location down here in the lab where the engineer can interact with the car and steer the car and gets real-time information from the car. Just imagine the engineer here wearing a head-mounted display. And in the movie, this car here in Korea is being shot at under heavy fire, but the engineer here in Africa survives this unharmed. But of course, we're not quite there yet, so we start a little smaller. We bought some IKEA lamps, a remote-controlled car, and a Vive tracker, and combined this and project this into virtual reality on our virtual remote-controlled car. And we plan to use this entire technology in a real project for our customer Deutscher Wetterdienst, and also in a little in-house project which Mike will tell you about in detail right now.
So I hope you can understand me. So clicking next. Yeah. I'm talking a bit now about connecting the real and the virtual world. So, what did we actually want to do? We wanted an interaction between the virtual and real world and influence the state of objects in VR and vice versa. Also, we wanted to use and enhance real-world objects in virtual reality, as I'm going to talk about now. So, where did we start for that? We modeled one of our office spaces. As you can see, this is our real office space. And with a little bit of imagination, you can see it exactly here in Unreal. And we bought some IoT sensors from our favorite Swedish furniture supplier and placed the virtual furniture on the same spot as their real counterparts. So what kind of interaction did we have? We had our IoT sensors and our smart home lamps in our real room, And in our virtual room, we had the ambient light, which we could control, temperature, humidity, and the lamp objects themselves. And we choose, for example, with our light sensor, to influence the ambient light of the room. Our temperature sensor influenced the tone of the light. So if it's more cold, the light has a more bluish tone. If it's hotter, it has a more reddish tone. The humidity sensor projects its input simply on a virtual tablet. And the smart home lamps recreate their state in virtual reality. So if they're turned on in VR, they are also turned on in reality and vice versa. So what kind of technology did we use? We first used Unreal Engine 4 as our engine to run our VR application and also to communicate with a server. So our server handles the input from Unreal and sends it to our IoT sensors and Raspberry Pi. Our server is hosted on in Amazon. It's an Amazon EC2 server, but you can actually use for that kind of application a local server as well. We just use it for portability reasons, so we could take and bring our app with us to different locations without having to host a local server there. So our router spans up a wireless LAN for our IoT sensor and provides internet for our smart home and Raspberry Pi. So our IoT sensors, they are mounted on a breadboard together with a particle photon. This particle photon connects automatically to our wireless LAN and sends the input to our Amazon EC2 server. The Raspberry Pi is used to communicate with IKEA smart lamps. Oh, I said the name, sorry. And the smart home kit informs the Raspberry Pi on any state change, which then again is forwarded to our server, which then again is sent to our VR application. So our components are listed here. We got our VR app, our server, and our real-world input and output objects. So this is our router. Here's our Raspberry Pi, smart home kit, and the IoT sensors. The data flow is as follows. The virtual reality app communicates with the server. The server then sends input and receives input from the Raspberry Pi. The Raspberry Pi controls the smart home kit. The smart home kit informs the Raspberry Pi of a state. And the IoT sensors, they frequently just post the state on the server. So here you can see our homemade real I/O board. Here's our smart home kit, the LTE router, our switch to provide the Ethernet. Our IoT sensors are not listed there, but we can show you later in the demo. So, how did we communicate with our server in Unreal? We downloaded and placed the Unreal Engine WebSocket plugin in the plugins folder, started Visual Studio, built the project, and enabled WebSocket in Unreal. So we could use a custom communication with our server. Unreal usually just supports communication for games. This is not quite that what we needed in this kind of project, so we used our own personal protocol. So, and when you import a plugin into Unreal, you can actually use the C++ code there. For example, the send text function, you can see right here. It's called from the blueprint script. This is our function send command, and as you can see, the white line is the execution flow. Basically, a blueprint script is a flow chart. You program it. Also, you don't like in a normal editor use programming language. You rather use components and define the execution flow. Colors are used for variables. For example, red is a boolean, blue is an object or reference, and purple is a string. So what this function does is it checks if the web connection object is valid here, basically not null, and checks if we are connected, and if these conditions are met, we call our send text function upon our WebSocket object, and the input comes also here from our command and target device ID, which are appended and separated by a slash, and then given as argument in the send text function. So what we then had was a very complicated way to turn and off and on lights, but it worked. So we also integrated leap motion, because in my opinion controllers still present some barrier to the immersion. For example, if you grab something in virtual reality, you usually use the HTC Vive controller or something similar, and the object is attached to that plastic controller rather than your hand. But it would be more natural to just use your hand, grab something, and have it in your hand. So we use Leap Motion for that. However, there's no haptical feedback yet. Luckily, HTC Vive released trackers, I think half a year ago or something, which can be attached to any physical object. So these objects can become anything in VR. For example, if you just buy a piece of wood, attach the tracker on top of it, it could become a tablet, for example. But you still have the haptical feedback of the wood, which might roughly be the shape of the tablet you see in virtual reality. And then your real hands, which are recreated in VR by Leap Motion, have that that sense of haptic feedback, which in my opinion is really interesting, because you don't grab something in the air, because you don't grab the air, but rather in a real object. So when you combine that, we had real objects in VR. So a smart home kit, the Leap Motion, and the tracker, and then you could control the objects from VR and also have the haptic feedback. And how this looks in motion, I will show you now. So does the play button work here? Ah, it does, perfectly. So as you can see here, one of our students turns on and off the light. Here we have our light sensor. When the hand is placed over it, the light goes on or off. And in the background you can see our office space in Darmstadt. So, thank you very much for your attention.